Hello and welcome to the calculator guide video on the two-tailed binomial distribution hypothesis test on the fx-CG50. So following on from our previous one-tailed test, we now have a two-tailed test for the binomial distribution. Let's take a look at the question. A random variable has distribution and then we've got x is distributed binomially and we've got an n value of 20 and a p that's yet to be defined, but we're going to take that from the null hypothesis. A single observation of x equals 6 is taken from this distribution. Test at the 1% significance level, and we have our two hypotheses already stated here for us. So our null hypothesis, h0, is p equals 0.55, and that's what we're going to be using as our p-value in the test. And then we have the alternative hypothesis here, h1, p does not equal 0.55. And this is the reason why we have a two-tailed test here rather than a one-tailed test. It doesn't say the alternative hypothesis that p is greater than 0.55 or less than 0.55. We've got to consider both possibilities. So therefore we want to consider both tails, both the upper and lower tail, and we've got to equally split the significance level between them. So if we've got a 1% significance level in total, what we're going to do is have 0.5% in the lower tail and 0.5% in the upper tail. So that's quite important. We've got to test both upper and lower tails in this instance. Let's have a look at the graph of the distribution so we can see it here. Now, our x value from the question there is x equals 6, but we have to consider more extreme results than 6. So we're thinking about 5, 4, 3, 2, 1, 0, all the way down there. And we have to include these more extreme values in it as well. So let's highlight those. Now you can perhaps just see 6 there, the column for 6, 5 in between 4 and 6 there is quite a small bar. And then we've got even smaller values, so even smaller probabilities for 0 to 4 on there, barely registering on the graph there. They're going to be very small probabilities, but we must include them. So our lowest value is going to be 0, and our highest most value is going to be 6 that we're going to be testing on here. So what we're really saying is that we're looking for the probability that x is less than or equal to 6. Now this is obviously going to be in the lower region. The lower tail is what we're going to be concerned about because we're thinking about the left-hand side of the graph here. And what we're really asking ourselves is that area there, is that area that's highlighted in the reddy pinky colour, is that or does that represent 0.5% of the graph there? Or is it less or is it more? And that's going to be what's going to be critical for this particular test. So let's input the information into the CG50. So from the main menu we want statistics, so navigate there, and we want F5 for distribution and F5 again for binomial. And then because we want up to and including 6, then we want binomial cumulative distribution, so that's F2. And then when we have the input page here, we want F2 once more because we want to input variables rather than a list. So as stated previously, our lowest value is going to be 0 that we need to include, and our upper value is going to be 6 in this particular case. The number of trials is 20, that's our n value from the distribution, and p, we're going to use the p from the null hypothesis. We're going to assume that that is correct, 0.55, and press execute. We're not going to save the results, just press execute once more. And here we have our critical value. So our critical value is going to be 0.02141435. Now let's just consider this as a percentage rather than a decimal. So we have to multiply it by 100. Well, that would be 2.14%. 2.14%. And we're comparing that against what we've got in the lower tail. We don't need to worry about the upper tail so much because 6 is quite a distance away from the upper tail. So we've already taken into consideration the fact that we've got a two-tailed test by reducing the significance level to 0.5%. So we are testing 2.14% against 0.5%. And what we can say is that 2.14% is greater than 0.5%. Now, because our result is greater than, therefore it's not lying within the critical region, which is less than 0.5%. So therefore what we can say is that there is not enough evidence to reject H0. There's not enough evidence from this particular test to reject H0, so we have to accept it. So therefore we can say from this test that H0 is true, that P equals 0.55. There's enough evidence there at the 1% significance level to say that that is true. So there we go, how we can test using a two-tailed binomial distribution hypothesis test on the fx-CG50. Once again, very easy to input the figures once you know all of the conditions and variables that you need to input. This question was quite generous to us in that it gave us a lot of the things already there, including our hypothesis. Obviously, the key thing there was that because you've got a two-tailed test, you need to make sure that you split that significance equally between the upper and lower tail. So you want half of your significance value in each. But that's it from this video. Thank you very much for watching, and I will see you next time on the Calculator Guide.